Hello, data pipeliners. Welcome back to another episode on Let's Write Pipes. And in today's episode, we're going to complete our Jupyter to Kedro notebook conversion with our final custom data set. And so the last time we left off after finishing completely our node creation, and the only thing that we have left to do is the integration of this Jupyter Notebook Folium mapping. And so Folium is a really cute little library. You can see here, it allows you to generate map locations and create these kind of like mapping structures within your IPython notebook. Now we want to have this functionality for ourselves as well. And so what we can do is we can try to figure out how can we create a data set that can utilize Folium. And so it's actually really straightforward. So the first step here is we take a look at our Folium documentation. So we go in here, Folium documentation. We're just going to Google it up, and we have our Folium documentation here. And so what we want to look for is we want to look for the ability to save. We want to look for the ability to output this map into some kind of file that we can then save with a data set. And looking here, we can see in the documentation right here, there is a index.html save function. So you can actually take a Folium map and then save it directly to disk. And so this is what we're going to do is create a data set that will allow us to save any of our Folium maps right there to disk based on a particular file path. So what this calls for is a custom data set. So let's go ahead and create that custom data set now. And what we're going to do is we're going to go ahead and open up our IO. So we already have a data set that we created before. Again, this is the GBIF request data set, which wraps around this GBIF request function that was part of the notebook to begin with. So now what we're going to do is create a Folium HTML data set. For the load function, what we're going to do is we're actually going to have it not return anything. So this is going to be a save only or a write only data set. So we can just raise a data set error, very similar to what we had before, where we say this data set is write only. Very simple. Then we add our describe function in order to make sure that we can have this data set show up very well inside of our logging. And then finally, we write our save function. And so the save function is actually super simple, right? So if we take a look here, again at the documentation shows that it really is a .save on a Folium map. So all we need to do here is just call that function. It's very similar to how pandas.csv dataset works. To help our quest, we can also import the Folium map data type. So we can just have it here to be explicit with the data types that are returned. All right, and that's all there is to it. Now we have our ability to save our data set. We just do the data.save to our file path. Now let's go ahead and add the appropriate nodes so that we can run this Folium. But right before we do that, again, as we learned from the last time, it's best to always check your data set to make sure that what you wrote actually does work. So I'm going to go ahead and start up a Kedro Jupyter Notebook. And so we have our previous example with the scientific name, Argia agrioides. We can go ahead and skip this example, and instead let's go ahead and import our current one. So this is from bnhm.io, import our data set. And now what we can do is we can actually copy the code from our quick start. And now we have a Folium map, which looks like it does work. Let's go ahead and create a new data set. And then let's pick a location to save. We're just going to go ahead and save to our local directory. And again, being able to use Kedro Jupyter Notebooks allows us to take advantage of the fact that all of the paths are already created and already set for us so that we can easily import our Folium HTML data set. So running this guy here, we create a new data set. and then we're going to call save on our M file. And that looks like it was successful. Let's go ahead and see if we can find that file. So going back here, here it is, our test HTML file right here available inside of the notebook. And there you have it. This is exactly the same as what we have here in our notebook itself. So that worked perfectly. So let's go ahead and add in the nodes and finish up this project. Thankfully, the writing of this node is actually quite straightforward. All we have to do is very similar to our last video, pick up the cells that we wish to create into nodes, copy and paste them, and then make sure that the data is available for our needs. So here we have our node that we wish to create, and this one will generate a map that will create these circles that correspond to collection codes. All we have to do is actually just copy and paste this node right inside of our pipeline. So let's go ahead and say get collection code map. This one relies on our records data frame, which is actually the base data frame here that everyone else relies on. And then it will return for us a Folium map. So we can import Folium and then just say the map that we're returning. Now, all we have to do is just paste in our code and then see what we need to transform. So here, right off the bat, we have our records data frame. This has been renamed for us to DF. And then we have this thing here, color dict. And so this color dict actually is an assignment dictionary, which is created up here in the cell prior. This cell actually relies on this function called assign colors. Lucky for us, the assign colors function is actually located inside of our ESPM module. So all we have to do is just import this assign colors and use it inside of our notebook as you would expect. So let's go ahead and do that. So now we have our color dictionary corresponding to our collection code values, and then all we have to do is return our mappa, which is the Folium map. And now we have for ourselves a brand new Folium map to use. Now, all we have to do is go ahead and tie that to the pipeline, and that should work out very well for us. So let's go ahead and do that here. Now, in this case, we don't have a custom data set created for us. So there's two things that we can do. One, we can either create the data set inside of our catalog, which is totally fine. That's very straightforward. All we have to do is go inside of our catalog and type in. And the type, of course, is our custom type, which is the nhm.io Folium HTML dataset. And the file path is going to be inside of our data/o1 raw, sorry, not raw, o3 primary collection code map.html. So we can use this in order to save, and we'll just go ahead and do that really quick, where we have our Folium map. And when we run this pipeline, let's go ahead and ensure that we're running the correct configuration, which should be the data science version or the default version, which will forego re-downloading the data, which is good for us. So let's go ahead and run that. And we should be able to see our brand new output inside of our data set. So here it is, collection code map, and it looks like it has HTML. Let's go ahead and try to open that up using our browser. And here it is. Of course, it worked just fine. So the next part we need to do is we need to create a few more nodes corresponding to some of the extra data related to the map. So first, let's go ahead and download the data that they're looking for. So they're actually looking to get some GeoJSON data from this particular URL. If we go ahead and run this guy, you can see in a bigger way the exact reserved data that we're getting out. So we can see it here. So this is all the GeoJSON data. And then what we can do is we can begin to extract all the reserves data that we need. And it looks like here, unfortunately for us, there was a problem reading some of the input. So it seems that this node in particular doesn't work. And unfortunately for us, I believe it's because this GitHub link here might not actually be available. And so if we look here, this multi-polygon works for this one, but maybe it's actually having an issue with perhaps one of them. So maybe Hoplin or C. Yeah. And so the Hoplin doesn't work as well as yeah, it's just Hoplin. So what we can do is you can go ahead and comment this guy out, and that's one of the unfortunate truths about using kind of old data, but we do have access now. So we have our reserves based on that GET request. We have this output from this reserve too, and then we can just check to see the reserves that we have available, and these are all of the reserves that we have available. And then what we can do is we can actually load this file into a Folium GeoJSON, and then append it, or rather add it to our mapping. And so this, for some reason, color dict wasn't available. Let's go ahead and rerun this guy for that. And then the radius is having an issue. And so what we're seeing now is we're seeing a lot of the old data and old code being a little bit tricky here. So we're missing a radius attribute. And so what we can probably do is we can add in one for ourselves. We can just say the radius is equal to 1. And now here it is. This is all of our little dots that correspond to the reserve locations. So the first thing that we want to do is, again, very similar to how we separated the previous pipeline, is that we separated between the loading as well as the running functions. And so what we want to do is we want to do all the loads, meaning like all of the long processes where we pull data from the internet in a separate pipeline than the one where we process the data. And this makes it easier and quicker to iterate on the data processing. So let's go ahead and do that. What we're doing is we're going to be creating a impure node. And so this is a little bit of breaking kind of the rules of Kedro, where we're using a node to generate data for us. Normally, you would find that a data set is the one that generates the data for us. In this case, it's going to be okay. And this is a very valid way to get your data. The reason why we can do it this way is because the data here is relatively specialized, and because it's relatively specialized, creating a brand new data set in order to handle it is not really a super useful approach. And that's because it takes time, of course, to generate these new data sets, and making sure that you're focusing the time that you have available to you in the right way is very important. And in this way, just having a simple node that will generate the reserve JSON for us is the most straightforward. Let's go ahead and use this guy here. We're going to grab this URL, and it's going to be get reserve data. And so it takes no inputs, and what it's going to do is it's going to output a dictionary. So let's go ahead and import that type so that we can keep it here, and then just start copying and pasting the code. So we have our URL, we have our reserves, and then we also need to import our requests module, so we can go ahead and import that locally, put it on top, and then scroll down here, we can grab the URLs that we need. And so you saw how we made sure that it's actually, that Hoplin doesn't work here. One more thing that we also have to do is we have to make sure that the mapping function is available and WKT. Let's go ahead and figure out what these guys are. So the mapping function, if we search inside of our notebook, we see at the very top, there is a reference to this mapping, and this comes from Shapely. So we can actually import the Shapely function here. So right here at the very top, just import mapping and the point, get rid of that. And then the other function that we're missing is WKT. And this also comes from Shapely. So we can grab Shapely as well. Here it is. So from Shapely, import WKT. And now we have all the data here. We can just return our reserves. So what's interesting is that what we can do here is now that we have this data, how do we actually add it to the pipeline? Very simple. We just go inside of our pipeline, the DE pipeline, and then we're going to add in this new node. And the node actually is going to be it's going to be this guy, of course, the get reserve data. So we can go ahead and import that. The inputs are going to be none because this node doesn't take any inputs. And then the outputs are going to be our raw data, and it's going to be reserves.yaml. And so what this is going to do is again going to use Kedro wings in order to generate a reserves.yaml file inside of our raw data folder. Alternatively, of course, we could just add in the reserves.yaml file here, but that is unnecessary for us since we are using Kedro wings. So now that we've added this guy in place, we can go ahead and try running the DE pipeline. So here it is. I've got the DE pipeline here. I'm going to click that run button, and we should get our raw reserves very soon. And it looks like it came just fine. If we take a look here, it has not reloaded. There it is, reserves raw.yaml. And this is all of our JSON data. And so what we can do here is utilizing that reserves data, we can create that final node here, which is this one, which allows you to have the dots here. So let's go ahead and grab this and then create our final node. We also need, of course, our data frame, which is our reserved data frame, and then our color dictionary, which will use the same dictionary as the collections code map. Arguably, you could just go ahead and set color dictionary as a separate node or a parameter potentially. In this case, we'll be fine to just regenerate the collection code color dictionary. Now that we have all of that, we can just return our map. And previously, I was talking about the multiple ways you could use or you could generate the catalog values for the map here. And what we can do is, of course, the catalog YAML file is one valid way. And the other way that we can do is we can use the run Kedro wings. And so this is what we had previously. We'll just go ahead and add this one in where you have a .html. And instead, we're going to use our custom type, which is our bnhm.io.folium HTML dataset. And so now what we can do is, instead of using the catalog, we can just generate our data sets right inside of here. So we have this collection, collection code Folium map. We can just do that inside of our primary right here. Collection code map, collection code.html. And then we can also add in our other new node, which is, and that takes our data frame as well as our reserved data, reserve.yaml. Let's go ahead and give that guy a run, and let's see what the output looks like. And now it looks like the collection code.html output, and that's because this should not be collection code, this should be reserve map. And let's try giving that one more time. And it looks like reserve.yaml doesn't exist, and that's because it should be reserves with an S. And it looks like a little bit of an issue loading the YAML data set. And so this means that there's probably some extra values that is coming back in the dictionary that is not supported by YAML. The most straightforward way to fix this is if we just go ahead and recreate the JSON data set. So the reason why we have to recreate the JSON data set, unfortunately, is because with the most recent version of Kedro, they had to take out the JSON data set. Not exactly sure why, but that's totally fine. I'm pretty sure that that'll be put back into place very soon, and if not, we can always make a pull request to help contribute back to the team to get the things that we need. And from here, we can, of course, add it either to Kedro Wings or to our catalog. I'm a personal fan of using Kedro Wings, where it's very straightforward to just go ahead and type it in and then get access to it immediately throughout the entire pipeline. And now that we've created this, all we have to do is modify our reserves. Instead of .yaml, we just change it to .json. So let's go ahead and reload and rerun the pipeline. Here we've created the JSON file already, so we should be able to see that here. And there it is, our reserves JSON. And now when we run our normal pipeline, and now we have our reserve map. Let's take a look. And here it is, exactly the same. And thus we end our Jupyter to Kedro journey. Thank you so much for joining me. And if you guys like this content, make sure you button that like, sub that subscribe, and ring that ding if you want to know when we are pipelining. And let me know if you guys find this content useful. I think that being able to translate between our Python Jupyter notebooks into Kedro pipelines is a very, very useful utility. And so if you guys really want me to make more of these videos, make sure you let me know, and I'll see you guys in the next one. Take care. Bye-bye.